Hello everybody. Today we will study about conformational parameter of protein. Before discussing the topic conformational parameter of protein, uh, let's have a short introduction about how peptide bond is formed. What is peptide bond? Uh, we are well familiar about amino acid. This is the structure of a single amino acid, that is NH2CHR C double bond OH, and this is another amino acid. What happens during formation of peptide bond, uh, H and OH is removed as H2O water, and this carbon and nitrogen makes a bond together, and this bond that is formed in between carbonyl carbon, this carbon with double bond O, this is called carbonyl carbon. This carbonyl carbon and nitrogen, the bond between this carbonyl carbon and nitrogen, this bond is called peptide bond. Now let's understand a simple structure of protein, how protein is formed. We already know protein is a polymer of amino acids, that is a group of amino acid are linked together by peptide bond to form a long chain of protein, and later on this in the protein folding process, this long chain of amino acid gets converted into protein. This will be discussing in further videos about protein folding and what is the process of protein folding. Here this H2N CHR C double bond O N, up to here you can see this is one amide group, this is another amide group, and after this N, and this continues till this continues to a long chain. This is the third amino acid. So in this structure we can see 1, 2 and 3 amino acid structures which are forming peptide bond. These are the peptide bond. This is the linear chain of structure of protein, and this is also called as a primary structure of a protein. Now let's discuss about what are the various conformational parameters of the peptide bond. Here you can see this this is alpha carbon. And what is this actually alpha carbon? That here in the diagram in primary structure you can see this the carbon with double bonded oxygen, this is called carbonyl carbon, and the carbon which is attached to other alkyl group and hydrogen, this carbon is called alpha carbon. So you can see that this carbon is alpha carbon, this carbon is carbonyl carbon, this carbon is alpha carbon, and this carbon is carbonyl carbon. So if I say alpha carbon, you should understand the carbon which is bonded to alkyl group and hydrogen, and if I say carbonyl carbon, carbon bonded to oxygen. Okay, now this type, this is the structure of alpha carbon. This is carbonyl carbon, this is nitrogen, again carbonyl carbon, sorry, alpha carbon, and this is carbonyl carbon, and this is nitrogen, and this small structure that you see here, these are the hydrogens. This is hydrogen. So NH, in previous structure we have studied this NH2 C double bond O, and this bond is the peptide bond. Similarly, here also you can see this alpha carbon, carbonyl carbon, and this nitrogen. This bond is a peptide bond. Is it? Okay. Now here one more thing about this structure that we need to understand. This nitrogen have 5 electrons in their valence shell, among which 3 electrons are participated in bond formation. 3 electrons are in bond forming, they are engaged in bond formation, and still this nitrogen have two electrons with him. The two valence electron is unbonded, and these two electrons are called lone pair, and this lone pair can migrate. Because of this migration, the lone pair, if it when it migrates to the bond in between the bonds of carbon and nitrogen, then a partial double bond character can form in between carbon and nitrogen. This is also theoretically or experimentally it is proved by various quantum mechanical and X-ray diffraction pattern. This also says the peptide bond is the partial double bond. This quantum mechanical and X-ray diffraction pattern both gives this carbon nitrogen distance as 1.325 angstrom. This distance as a 1.325 angstrom, which is very close to carbon nitrogen double bond, which is about 1.25 angstrom. Now let's come to the this structure. The bond between this alpha carbon and nitrogen, this bond is called Phi bond, and the bond in between alpha carbon and carbonyl carbon, this is called Psi bond. In previous structure you can see here that this alpha carbon, this is alpha carbon and this is carbonyl carbon. The bond between this alpha carbon and carbonyl carbon, this bond is your Psi bond, and the bond between nitrogen and alpha carbon is Phi bond. Now let's talk some more detail about this structure. Let's name these atoms with some labels. Let's say this alpha carbon as alpha carbon -1. How this name is done in this structure? For this, let's understand in solution. This alpha carbon, this carbonyl carbon. Up to here, it is one amide group, and this nitrogen, alpha carbon, carbonyl carbon. This is another amide group up to here, and this is the third amide group. So here also the three amide groups are there. This is one amide group, and this is another amide group up to this nitrogen, and this is third amide group. So namely this the lower group, we say this is -1, and these are 1, and these are +1. So let's name it this alpha carbon -1, this is carbonyl carbon -1, this is oxygen -1, this is nitrogen, this one is hydrogen. So nitrogen 1, hydrogen 1, alpha, this is alpha carbon, you can say this is alpha carbon 1, and this is carbon 1, oxygen 1, nitrogen +1, hydrogen +1, and this is again alpha carbon +1. Now this structures, this -1 oxygen, C -1, N1, H1, these all lie in a single plane. These structures lie in the single plane, and similarly this oxygen 1, carbon 1, hydrogen +1, this hydrogen +1, nitrogen +1, these structures lie in one plane, and this plane can rotate about this alpha carbon in this way. You can see the rotation axis over here. This way this plane can rotate, and this plane can rotate in this way. You can see the rotation axis of this plane, and this is the rotation axis of this plane. Now see, if this plane can rotate from 0 degree to 360 degree, and what we say, the upper half rotation is 0 to 180 degree, and the lower half rotation, it is called 0 uh, 0 to minus 180 degree, we say this one in Ramachandran plot. Later on we will discuss about this 0 to minus 1 and 0 to plus 185 and 0 to 180 psi and 0 to minus 180 psi. How this is explained in Ramachandran plot, we will discuss about it in coming videos. One more thing that we need to know about this structure is the double bond character and the transposition of this hydrogen and oxygen. In the structure, what we can see, this oxygen and hydrogen, they lie at the transposition. This transposition of oxygen and hydrogen is quite more stable than cis position of this hydrogen. A cis position means if they lie in the same orientation, that is, if hydrogen also is bonded to the same orientation, then this is called cis position. But cis position is not possible in this peptide bond and this yes, in this peptide bond, because transposition of hydrogen and oxygen is more stable than the cis position by 4 kilocalorie per mole of energy. Things will be more clear if we if we watch this small animation. Here what you can see, that this carbon is the alpha carbon, this is the carbonyl carbon, this is nitrogen, and the bond between this alpha carbon and this nitrogen, this bond is called our Phi bond. And you can see here, if this lie in, or this carbon and oxygen, if this carbon oxygen these are aligned in this way, then this is the phi is equal to 0 degree, means simply the both the plane, this plane of this alpha carbon and plane of this phi bond plane, they are parallel to each other, that is phi is equal to 0 degree. Next you can see here, if I rotate this in opposite direction, now the angle in between this carbon and oxygen is 180 degree. Now let's rotate in opposite about psi bond. This carbonyl carbon and this carbon is called psi bond, and if we rotate this one, you can see the plane of alpha and the plane of this blue structure. You can see if they lie in same plane, then this is 0 degree. If this way it is aligned, and if it is rotated in opposite direction, that is opposite half rotation, if it is there, then this angle is 180 degree. So this is the conformational parameters of the peptide bond. In conformational parameters of peptide bond, we came to know that there is a double bond characters in between this carbonyl carbon and nitrogen, because of which this carbonyl carbon and nitrogen do not rotate, because of this double bond rigidity. This bond do not rotate, but the rotation can take place in between this phi and psi. Just now we saw here this alpha carbon and this carbonyl carbon, this bond can rotate, and this bond can rotate. Alpha carbon and this nitrogen phi bond can rotate, but the rotation is not possible in between this carbonyl carbon and nitrogen. It means these bonds, this carbonyl carbon and nitrogen, carbonyl carbon and nitrogen, These bond do not rotate because of partial double bond character. So this is about the conformational parameters of peptide bond, in which we studied about uh, what is psi bond, what is phi bond, what is their possible angle of rotation if it is rotated. Yes, one more thing that we need to understand is that this the angle between the planes, these are called dihedral angles or torsion angle. So remember what is torsion angle. Torsion angle is not in between angle in between two lines, it is the angle in between two planes. In the coming next video we will discuss about what are the conformation of peptide chain, in which we will discuss about the various primary, secondary, tertiary and quaternary structures of the protein, and then about Ramachandran plot, and then protein folding, what is about the process of protein folding, how means it is just we will discuss about how this long chain of amino acid gets converted into protein, and then we will discuss about and we will differentiate this antibody and antigen. What is antibody and antigen? Stay tuned for the coming videos. Today for this much. Bye bye, thank you.